But imagine for a moment that you're an explorer, not of oceans or jungles, but of reality itself. Now, whenever explorers set out, there's always this quiet assumption in the back of their minds. There's something out there to reach, a boundary, a shore, an edge. Naturally, we carry that same instinct into the biggest question of all, the universe. We ask, where does it end? And more curiously, did you get there? But here's where things start to get strange. Because the universe doesn't behave like a map. Otherwise, we give you a line that says, stop here, nothing beyond this point. In fact, the more we learn about space, the more it seems to resist the very idea of having an edge at all. So tonight, instead of trying to give you a neat answer, I want to do something a little more fun. I want to think with you. I want to poke at this question, turn it around and see what breaks and what doesn't. Because sometimes the best way to understand the universe is to ask a question that might not even make sense. Imagine for a moment that you're an explorer, a ship or sails across oceans or treks through dense forests, but something far stranger, an explorer of reality itself. You don't carry a compass or a map because there isn't one. There are no marked paths, no warning signs, no you are here dots, just questions, big ones, the kind that don't sit still. Now, whenever explorers set out, there's always this quiet assumption tucked somewhere in their thinking that eventually they'll reach something, a coastline, a wall, a final step where the journey runs out. And even if they don't say it out loud, they expect there to be a boundary, a place where the unknown finally stops. And really noticing it, we carry that same assumption into the biggest question we can possibly ask, the universe itself.
The universe itself.
We look up at the night sky, at all those stars scattered like sparks, and we wonder, how far does this go? Not just in distance, but in principle. Does it keep going forever, or does it stop somewhere? Does stop? What exactly does stop even mean in this context? Because you see, when we think about edges, we're usually thinking about familiar things. A table has edges, a room has walls. Even the earth, which feels vast, has a surface you can walk all the way around. But all of these examples have something in common. They exist inside something else. Paper sits in a room. A boom sits in a building. It floats in space. So when we ask whether the universe has an edge, we're sneaking in a hidden assumption that there's something outside it for that edge to separate us from. The assumption doesn't work anymore. What if the universe isn't inside anything? That's a clear thought because it pushes us into unfamiliar territory. Our intuition starts to wobble a bit. We're used to edges being borders between two things, this side and that side. But if the universe is everything that exists, then what could possibly be on the other side of its edge? You might imagine flying in a straight line, faster and faster, crossing galaxies, passing clusters of galaxies, moving through the vast emptiness between them, always expecting that at some point arrive at something like a wall. Maybe it's invisible, maybe it's made of something exotic, but something that says that's it, no more beyond this. That's what happens if you try to go past it. Do you bounce off like hitting glass? Do you bounce off like hitting glass? Do you disappear? Do you somehow slip through into something else? Else that wasn't that part of the universe too. This is where the question starts to twist in on itself. Because the more seriously you take it, the more it challenges the way we normally think about space. It's not just about distance anymore. It's about the very structure of reality. But doesn't need an edge in the way we expect. Maybe it can curve back on itself, like the surface of a sphere where you can travel forever without ever encountering a boundary. Again, that idea brings its own kind of confusion. If you never hit an edge, does that mean the universe is infinite? Hid in a way that doesn't require a boundary. And suddenly, what seemed like a simple question, does the universe have an edge, turns into something much deeper. That becomes a question about how we define place, how we imagine outside, and whether those concepts even apply when we're talking about everything that exists. Let's push this idea a little further. Now, let's take a slightly different angle on this idea, because so far we've been imagining ourselves traveling through the universe as if we could chase down its limits. But maybe that picture is misleading from the very beginning. Instead of thinking about moving through space, let's think about what space actually is. Space is some kind of stage, an empty backdrop where things happen. Stars sit in it, galaxies drift in it, and we move through it. It feels passive, like a container. But modern physics suggests something far stranger. Space isn't just a container, it's part of the system. It can stretch, bend, curve, and even carry energy. Then asking whether space has an edge is a bit like asking whether the surface of the Earth has an edge. But even that comparison doesn't go far enough. On Earth and start walking in a straight line, you never fall off. There's no boundary where the ground suddenly stops. Then you eventually come back to where you started. The surface is finite, but it doesn't have an edge. It curves back on itself. Now imagine something similar, but in 3 dimensions instead of 2. Space that is finite, meaning it has a limited total size, but still has no boundary anywhere inside it. You could travel forever and never encounter a wall, never reach a final point, never find a place where the rules break. A strange idea, because it separates 2 concepts we usually tie together, finiteness and edges. We're used to thinking that if something is finite, it must end somewhere. Here is a case where it will be finite and yet have no ending point at all. And then there's an even more unsettling possibility. What if space isn't just curved in a simple, way, like the surface of a sphere, but in a way that we can't easily visualize? Higher dimensional curvature, shapes that don't have direct analogies in our everyday experience. In that case, even the idea of going straight might not mean what we think it means. To be traveling along what feels like a straight path, but the geometry of space itself could be guiding you in ways that are impossible to notice locally. No signposts, no distortions you can feel, just a quiet, hidden structure shaping your motion. And if space can behave like that, then the idea of an edge becomes even harder to pin down. An edge would have to be something detectable, something that stands out against the rest of space. But in a universe where the geometry itself is flexible and dynamic, an edge might not even be a meaningful feature. There's also the question of time mixed into all of this. A bit talk here again about space as if it's frozen, like a snapshot. But the universe evolves. It had a beginning, at least as far as our current theories suggest, and it has been expanding ever since. Looking for an edge. Are you looking for it in space or in time? Could the edge of the universe be something like the beginning of time itself, rather than a place you could travel to? Again, the idea comes with complications, because time doesn't behave like a simple line either. Near the earliest moments of the universe, our usual understanding of time starts to break down. The equations we rely on stop giving clear answers, and we're left with models and approximations rather than certainty. So now the question has shifted again, no longer just about whether the universe has an edge in space, but whether the concepts of space and time are even the right tools for describing the ultimate structure of reality. And the more we follow this line of thought, we start to see that the idea of an edge might not be something waiting to be discovered out there, but something that arises from the way we try to describe the universe in the first place. Suppose now you could actually travel across the universe, not just in the sense of moving fast, but truly crossing unimaginable distances, billions of light years without aging, without running out of time, just continuing steadily in one direction. No turning back, no shortcuts, just a straight path forward. At first, nothing unusual would happen. Path starts, then leave them behind. You would drift through regions where galaxies are dense and crowded, and then through enormous stretches of emptiness where almost nothing exists at all. As we can tell, is mostly empty space with occasional islands of matter scattered throughout. But as you keep going, a strange question begins to grow. Are you actually getting closer to anything like an edge? Or are you just seeing more of the same pattern repeated over and over again? Because here's the tricky part. The universe isn't just sitting there waiting for you to cross it. It's changing while you move through it. It itself is expanding. Galaxies aren't simply placed inside space like objects in a box. The very distances between them are stretched. As you travel forward, the universe is quietly rearranging itself, making the idea of reaching a final boundary even more slippery. Now imagine you're still going further than anyone has ever imagined, and you start noticing something odd. The further you look, the less you can see. Not because there's nothing there, but because light from very distant regions hasn't had enough time to reach you yet. Kind of horizon, not a physical wall, but a limit to what information can reach you. And it's tempting to confuse that horizon with a grand edge. But it isn't. It's just a limit of observation, not a limit of existence. So even if you kept traveling, chasing that horizon, it would keep shifting. Various others would come into view, others would slip away, and the idea of a fixed endpoint would remain just out of reach. Like trying to walk to the horizon on Earth, it always seems like a definite place, but it moves with you. This leads to an even more curious possibility. What if the universe doesn't have an edge in space, but only limits in what we can observe? And if that's true, then the question changes. Where does the universe end? But rather, what does it mean for something to end at all? We're so used to boundaries being physical, tangible things. Walls, surfaces, borders. But here we're dealing with something that might not fit into those categories. Now consider another twist. If the universe did have an edge, it would have to behave in some consistent way. Wouldn't suddenly stop making sense at that boundary. The same rules that govern everything else would have to apply there too. What kind of rules could describe an edge of everything? Would space simply stop existing? Yeah. And if so, what does it even mean to approach a place where space itself disappears? You see, every attempt to picture an edge ends up relying on ideas that assume something beyond it. And that's where the difficulty lies. Our brains are built to understand objects within a larger context, but here the universe is the context. Finding a neat answer, we end up uncovering something more interesting. The possibility that the question itself is pushing against the limits of how we think. Not because it's meaningless, but because it forces us to rethink what we mean by space, distance, and even existence itself now. After circling around this idea from different directions, I'm asking a slightly uncomfortable question. What if the problem isn't the universe at all, but the way we're trying to describe it? At an edge, we borrow in a concept from everyday experience. Edges belong to things. Tables, rooms, books, planets. They mark a boundary between one region and another. They only make sense when there's something on both sides. This side and whatever lies beyond it. The Tao of the universe isn't just another object sitting in a larger space. It is the space, the stage, the entire set of things that exist. We attach an edge to it. We're quietly assuming that it behaves like the objects we're familiar with when it might not follow those rules at all. Physics becomes less about finding answers and more about refining questions. A good question in science isn't just one that sounds interesting. It's one that can actually be framed in a way that nature can respond to. Sometimes a question that seems perfectly reasonable first that turns out to be built on assumptions that don't apply to larger scales. Asking where is the edge of the universe? We might ask something more precise. What do our best theories say about the structure of space? Or, according to modern cosmology, especially the framework built on general relativity, space doesn't need an edge to be complete. It can be finite or infinite, curved or flat, expanding or evolving, all without requiring a boundary in the usual sense. The equations describe how space behaves locally and globally, but they don't demand a stopping point. Let's just actually look for evidence of an edge. Something observable, something measurable, something measurable. They don't find it. There's no signal, no abrupt change, no feature in the data that suggests we're approaching a boundary. Everything we observe fits smoothly, extend beyond what we can see, but that doesn't mean the question is useless. In fact, it does something very valuable. It exposes the limits of the intuition. Our intuition is built from living in a small corner of the universe, dealing with objects of a certain size, moving at certain speeds, under certain conditions. It works wonder for everyday life, but when we stretch it to cosmic scales, it starts to give misleading answers. And that's not a failure, it's a clue. The universe operates on principles that aren't always aligned with our everyday expectations. And that's that we have to be willing to let go of certain assumptions, even ones that feel completely natural. The when edge becomes less about a physical boundary and more about a conceptual boundary. How far our thinking can go before it needs to change shape. Explorers once had to abandon the idea of a flat Earth to make sense of global travel. We might have to abandon the idea of edges to make sense of the cosmos. At least that's fine about that, because it means the universe isn't constrained by the limits we imagine for it. It doesn't owe us a neat border or a clear endpoint. It simply exists under following its own rules, inviting us to understand it, not by forcing it into familiar shapes, but by slowly adapting our thinking to match its structure. And in that process, the question itself transforms from where is the edge into something quieter, but far more profound. What kind of thing is the universe that it might not need one at all?